Hello everyone, myself V.V.Gopala, Assistant Professor, Department of Computer Applications, Aditya University. Today I am going to discuss some topics related to flow control and error control. This flow control, error control are very important procedures you have to follow for the actual controlling of the flow, and as well as for actually finding out the transmission of data in a reliable manner. So now before going to the actual lesson, let us consider that after completion of the lesson, the user or the student is expected to know about the introduction of flow and the control, error control, and also about the noiseless and noisy channels, and also about the protocols for noisy channel. And we are going to know the basic steps of the stop and wait ARQ. So these are the things we are expecting. After completion of the lesson, student can be able to familiar about these things. Topic or a point related to the flow control. Flow control refers to the set of procedures which are actually meant for controlling or restricting the amount of data to be transmitted from the sender to the receiver, and this particular kind of thing is basically depending on one important factor that is called an acknowledgement. So basically this is an acknowledgement based kind of a transmission we are expecting to control the flow. Without any acknowledgement, suppose you continuously transfer or transmit the frames, put it in the data link layer, then there may be a chance of losing some data frames, so that ultimately the meaning of the message may be lost. So that is why the flow control actually playing a very important role as far as the data link layer responsibility is concerned. And of course, error control is another step which is to be carried out by data link layer, which is actually meant for controlling the errors by controlling the flow basically, and also by controlling the actual errors by actually finding out the retransmission of data based on the acknowledgement that is actually made by the receiver. Suppose you are a sender and there is one receiver that is there, you are sending some frame to the receiver. So you cannot continuously send the frames without any acknowledgement from the receiver, unless you are confident or unless you are clear that whatever the frame that you are releasing is received by the receiver. There is no point of communicating all the frames without any confirmation like that. So that is why to the actual error control, there is a very important step that we are following, that is acknowledgement. So here, based on the acknowledgement only, the sender will decide what type of or how many frames are to be again retransmitted, and how the frames can be placed. All these things can be identified by the actual sender based on the acknowledgement that is made by the receiver. So that is why these things, that means the flow control and error control, are very important as far as the actual reliability of data is concerned, and the control of the flow is concerned. Of course, there are two types of channels we are expecting in the data link layer, which is actually the above layer of physical layer, so that very close to the channels and their establishment, so that we are finding out the channels are actually classified into two ways. One is called as a noiseless channel, other one is a noisy channel. Of course, relatively there are certain protocols assigned for each and every channel that is actually shown on that. This is the slide which is saying you, or the slide that is showing that what are the protocols available for noiseless channel and what are the protocols available for noisy channel. Of course, in the previous session we have completed that the protocols available for noiseless channel. Now we are focusing on the protocols available for the noisy channel. Before going to the details of the noiseless channel and the noisy channel protocols, let us consider that what actually the meaning of a noiseless channel. So a channel which is actually ideal, in which no frames are lost and no frames are duplicated and no corruption can take place with respect to the frames once they are okay, from the sender to the receiver. They are traveling and finally they are reaching to the destination in this channel. So that is why this channel which is actually going to establish these kind of things can be referred as a noiseless channel. That means there is a guarantee that whatever the frame you are sending to travel to the receiver, definitely it will reach to the destination or to the receiver, and finally the receiver is able to identify all the frames which are actually sent by the sender in a same sequence. So that is about the noiseless channel. But practically speaking, it is very difficult to establish a noiseless channel because it is very expensive. Then what? Then we have to limit to the actual thing to a noisy channel. Noisy channel, of course, this is a channel where you can expect the frames that are actually maybe lost and the frames may be duplicated or the frames may be corrupted. So that is why this particular channel can be referred as a noisy channel, because the channel is shared by so many okay devices. Between so many devices the channel can be shared. So there are certain things you can identify in this case. That means the frames may be lost, the frames may be duplicated, or the frames may be corrupted because of certain reasons. So that is why this channel is called as a noisy channel. But we must be very careful about okay, conducting the flow control and error control with respect to the noisy channel. So basically the first and foremost protocol is stop and wait, ARQ. Here ARQ stands for automatic repeat request, and the second one is called as go back NARQ. Here N stands for the frame that is expected by the receiver to carry out in the next stage, and the select to repeat ARQ is another protocol which is meant for on a selective basis. Instead of sending group of frames on a selective basis based on the receiver, the respective frames can be transmitted to the receiver. So that is also on request only. So all these are based on the request. So that is why the total things or the total protocols are classified as automatic request protocols. So without any requests, you will not interfere in this transmission. So based on the interest of the receiver only, you are able to okay, designate what type of frame is which frame is to be okay, put it in the transmission, that you can able to decide. Let us start with the stop and wait ARQ. So this is the thing. This is a picture which is actually showing about so how you can able to control the flow. So here you first of all I have to say what are the main portions in the particular picture. First, A is a sender, B is a receiver. And if you come to the left side portion, that is a start and stop, a clock is maintained. That is only to estimate the total time that is taken up by the transaction to carry out. Once the transaction is going beyond the timeout, then automatically sender can take a decision based on that. And if you see the frames are actually nothing but numbered as 0 1 0 1 0 1. That means whenever sender is sending frames, the frames are numbered as 0, after that 1, again 0 1. That means it follows the numbering concept by following the modulo 2 arithmetic. That means suppose you have 7 frames, let us say 7, you cannot identify 7, you should not designate to the frame. So 7 should be divided by 2, and whatever the remainder that you are going to get, so that will be the frame number you can able to designate to the in this particular scenario. So like that, so any frame you want to send, so it should be numbered either 0 or 1. So that is a way how the frames are actually numbered as 0 1 0 1 0 1, like that. And of course, so that is about the sender side. Of course, request, you are finding arrival and after that request. So you will see the actual procedure once we take up an example. And if you come to the frame 0, that is in the transmission. So first of all, the sender is sending one frame which is numbered as frame 0, let us say, and it is received by the receiver, let us say. in a simple case. And after that, we are expecting an acknowledgement from the receiver. So that is shown in the ACK1. So based on that, the sender can able to decide what is to be carried out next. So now this is the way how the actual thing is represented. Of course, the timeline is shown here to estimate the timeout and also the in time whether the transaction is carried out or not. Based on that, the sender can able to take some other decisions. So let us start with a small example. Let us start with the sender is initiating the job by taking the frame number 0 here. So once the frame number 0 is transmitted, so there is a chance of reach to the destination the frame successfully, or there may not be a chance of that. So let us imagine that in a simple case, the frame 0 is reached to the destination in a successful manner, and receiver B is receiving that in a successful way. Then what the receiver has to do for the response of frame 0, what the frame is expected by the receiver is nothing but frame number 1, because no consecutive zeros or no consecutive 1 frames will not be delivered or will not be actually put it in the transaction. So alternative zeros and 1 numbered frames will be actually put it in the transaction, so that once the frame 0 is reached to the destination receiver, and the next frame that is expected by the receiver is definitely frame number 1. So what actually the receiver is doing is, it is saying that an acknowledgement by indicating ACK1. What do you mean by that ACK1? ACK1 is saying two important things. One is called as the previous frame is received by the receiver correctly, and it is expecting the other frame which is numbered as 1. So this is the reason, that is the communication that is made by this particular information ACK1. So based on that, let us say that now if you come to the sender side, then the next session is taken up by the sender by sending or by putting frame number 1 in the actual channel. Of course, there is one information I am going to say, that if you focus on start and stop, the first step, that means sending of frame 0 and getting of acknowledgement 1, is actually in time. So there is no ambiguity by the sender whether the frame 0 is received by the receiver or not. So because the acknowledgement is received by the sender in time, so that it is called as in-time transaction, you can call. But this is not possible in all the cases. That also we are going to see in this case. Suppose the sender is sending the frame number 1 in the next transaction as shown in this. So that is the frame number 1, and frame number 1 is put in the channel because it is a noisy channel. So due to some reasons, the frame 1 is lost. So the receiver will not get any kind of information because it is lost in the transit. So receiver will not get any symbol. So that automatically the sender is now waiting. Sender is waiting till at what time? Now after timeout. That means what actually the timeout means? That means the sender will calculate the time of travel by the frame from the sender to the receiver, and again from the receiver to the sender. What time actually is taken up here? So that can be called as the travel time, and of course or you can also call it the round trip time. And for this, let us imagine that the sender is sending the frame, and it is expected that the sender frame should receive to the destination in 1 minute, let us say. Again, from the receiver to the sender, we are expecting the acknowledgement in 1 time or 1 minute. Then what will happen? So for sending, for traveling in a forward direction, you require 1 minute, and for getting back the acknowledgement, you require 1 more minute. So totally 2 minutes is the round trip time actually we are able to identify. So the clock is set for 2 minutes. Once the transaction is conducted in 2 minutes of time by getting the proper acknowledgement, then you can say that it is a successful transaction. So if you see the second case, that means once the frame 1 is actually put it in the actual channel, but because it is lost, then the sender is waiting for 2 minutes. even after 2 minutes it is not getting any acknowledgement from the receiver, so automatically it expects that the frame is lost. Then the frame 1 again resent by the sender, and the frame 1 is there in the channel, and frame 1 is now by chance now it is actually received by the receiver in a successful manner, like this, as I am showing that in the figure. And of course after receiving that frame number 1 successfully, then the next frame what the receiver is expected is frame number 0. Then it is saying that ACK 0. Then ACK 0 is nothing but acknowledgement for the previous one, and also what is the actual expected frame next by the receiver is identified in the ACK 0. Now that is actually coming to the actual sender. Then sender is able to acknowledge it that, and it can decide what is the next frame to send. So that is about the second part. So now we have seen that the successful way of conducting the step number 1, and the successful way of conducting step number 2, even if the frame is lost because of the timeout concept, you can able to retransmit the frame that is actually expected by the actual the receiver. So now coming to the third case, that means here the sender is actually if you see the figures, the sender is actually sending one frame called 0 number frame, and of course it is there in the channel, and it is received by the receiver properly. Of course the acknowledgement is also made by the receiver saying that ACK1 is again revealing two important things. One is called as the ACK1 says that the previous frame which is numbered 0 is received properly, and which is expecting the other frame which is numbered as 1, but that acknowledgement is lost because of some problems that are there in the actual channel. So that what will happen is now here again the sender is waiting there on the other side till timeout. Once the timeout is happened, then automatically sender will feel that the frame is not received by the receiver, even though it is received by the sender successfully, but because of the acknowledgement is lost in the channel, so sender will feel that the frame is not reached to the destination properly. Again he transmit the frame 0 in the channel. Then the receiver again receive the same frame, and because I already told you that no two consecutive 0 frames or no consecutive 1 frames will not be received by the receiver. This is actually a policy. Then immediately after getting the again same 0 frame, then it understands that it is a duplicate frame, then automatically it discards whatever the recent frame that is actually been in the transit, it will be discarded by that. Again ACK1 will be sent to the actual to the sender. Then ACK1 revealing two important things. One is called as frame number 0 is received properly by receiver, and it is expecting frame number 1 in this case of this ACK1, and it is received by the sender in time, so that the sender can able to arrange for the sending the frame number 1 in the actual the transaction. So this is the way how the overall the steps can be carried out. So here how do you say that this is related to the flow control and error control? One is called as how many frames are to be put it in the channel, that is clear here. And suppose the frame is lost, it is an error you can call. Suppose the acknowledgement is lost, that is also an error. Suppose the frame is duplicated, even that also can be taken up care by this particular procedure. So that is why this particular kind of procedure is called as stop and wait ARQ. Here the word ARQ resembles that the sender will not decide which frame is to be sent. The sender is only decide based on the actual the request that is made by the receiver in the form of ACK. Suppose ACK1 says that the receiver is requesting for the frame number 1, and ACK0 says that the receiver is expecting the 0 frame. So this is the way how the actual ARQ is playing a very important role in this case of stop and wait ARQ Okay, so that is why this particular procedure, once it is carried out properly, so you can able to say that the flow can be controlled as well as the errors can also be controlled in this case. But of course, this is not very efficient, because suppose the bandwidth is more, that means bandwidth in the sense, suppose the channel is having a very very huge capacity of sending the frames, but similarly the round trip delay is there, then automatically this process is not an efficient process you call, because the large bandwidth means so much of data you can put, so much of number of frames you can put, but suppose you are also encouraging for longer ranges of transmission, then also you can say that the round trip takes more and more time, so automatically it creates some delay, so that this stop and wait ARQ is not actually relevant for efficient kind of transactions you want to conduct. And also this particular problem can be also called as a bandwidth delay problem. So this you can expect in the actual stop and wait RQs. Thereby you can reduce, or thereby you can say that this particular stop and wait RQ is not very efficient. And also it will not encourage any kind of pipelining. That means once one frame is there in the actual channel, so you cannot recommend the other frame also to occupy the same channel, so no pipelining is possible, so thereby it reduces the efficiency of the actual stop and wait ARQ procedure. So by this I say that the student is able to understand about the flow control, error control definitions, and also what actually the meaning of noiseless channel and a noisy channel, and also about the protocols for noisy channel, and we know the details of actually the stop and wait ARQ. Thank you.